Hello, and welcome to a demo for my multi-threaded client-server chat room application written in Rust. It uses the command terminal as the interface for all the members of the chat room. So, some background on this before I go into the code explanation and the demo. I wrote this project as a final for my programming languages class back in winter, I think, of 2020. So this came at a pretty interesting time in my coding career because I was just starting to get into some more complicated stuff. As you can see, multi-threaded application is a bit more complicated than some of the introductory coding that I had been doing before. But I hadn't yet learned a lot of the important mature lessons that you need as a programmer to build bigger projects. And at the time, this was a bigger project for me. So I'll basically quickly explain what my first approach was and what that led to. At first, all I had was an idea. I knew I wanted a client to connect to a server, and then anytime a client sends a message across a TCP connection, the server will then relay that message to all other clients in the room. And this is great. This is actually what I ended up writing. The issue was my first approach, I basically just wrote 300, 400 lines of code, compiling here and there, but never actually once testing whether things were working. And so what this led to is a jumbled mess where nothing worked, and with about a week to go, I had to completely restart my project, which led to a great deal of panic. Needless to say, I learned my lesson, and it's a mistake I've never made again. I program a lot more maturely now, where I think back to this, and you need to make small, testable, modular components that you can trust work before moving on to bigger things. And so the first thing I did when I restarted with about a week to go was I made sure I could send a message, any message. And then once I got that working, I built the bigger system you see now. So why Rust? At the beginning of my programming languages class, we were prompted to choose any language that wasn't going to be covered by the course material. And I had just gotten out of a computer networks class in the quarter prior, and so with that information fresh off my mind, I was kind of interested in choosing a fast language like C. C was what we had written, what we had used in the computer networks class. And I was fairly familiar with C++, and on looking up good programming languages as alternatives to those, obviously Rust came up, and that was my main motivation for choosing it, but I was also endeared by the idea that in a poll that I found, Rust was the most beloved language above all. So I ended up building this, and it was a little ambitious, obviously, but it ended up being a really instructive project. More probably than anything, it was just a lesson to me in how to program something big and expandable. Okay, the next thing I want to do is quickly go over the code before demoing, just to give an idea of what it's doing and in what order. So we're going to be looking at the server side's main function, and that'll give, I hope, a general picture. So the first thing we do is we create the TCP listener that just binds to an IP and a port. I chose the localhost IP and I think port 7878. Doesn't really matter, but there's that. And then the very next thing we do is we create this thread pool. And basically a thread pool is a way to designate a certain number of threads that you can then assign at any moment, and you'll see we'll get to it, but this is a a call to the thread pool where we spawn a thread that has this job. I'll quickly go over the implementation for it. You can see a thread pool is just a collection of workers and then a sender which can send whatever job that you specify to whatever worker is next available. The implementation for this I was kind of handheld through making by a Rust documentation project by example type of situation, where I sort of just followed along as they were going through a multi-threaded problem, and that was their solution to it. The next thing I do is I create my list of clients. You can see it has a size of max clients, and what it is a hash map that maps the username of that client to their TCP connection. You'll see where we create the username going forward, and of course it has to be unique, otherwise the hash map would kind of be a moot point. Don't really need to mind the arc or the mutex here. Mutex is for thread memory safety, so only one thread can access things at a time, and arc is just a Rust solution to ownership of data that allows it to be done safely. So again, up here we have, or down here, we have our first job for one of our threads in the thread pool to execute. And what it is this is the job that waits for messages to be received by any potential client, and then when that message is received, we want it to be broadcast to all the other clients. This plan was sort of outlined before, and this is so this should be pretty straightforward. This is the first job that we have. And the next thing we do is we process incoming connections. So this is kind of a messy jumble of code that I definitely would have written better if I had more time and yeah, maybe a little more experience, but here's what it looks like. The first thing we do is we declare a bunch of variables for reading and writing to a buffer, and then we check whether the client has joined we check whether there's room for the client in the chat room or whether the chat room is already full. If it's not full, then we prompt the user for a username, and if they write a username that is unique, we register that person into the chat room. And finally, call this handle connection function, which waits for a message to be sent. It writes the message to the buffer, and then it tells that sender, and this is that sender for this task right here, that it's time to broadcast a message. So the sender sends to the receiver says, okay, I found a message, let's broadcast it. That's pretty much the gist of it, and I will go ahead and start demoing now. So you can see worker 0 got a job executing. What that job is right here. It's that polling system waiting for a message to be sent. And then let's start making our chat room participants. We've got Alice first, followed by Bob. And we'll test a few things here, a few potential errors. Let's see if we can enter Bob again. Looks like that username is taken, so that error case is handled. We'll keep going down the alphabet then and choose Charlie. And lastly, we'll do yours truly, Daniel. So the other error we want to test, can we join when the room is already full? It looks like no, so we're going to follow the rules and just quit out and quickly show that the server is processing all of these things and returning the right messages. Okay, and lastly, as it's a chat room, we should probably test whether we can actually send some messages. So we'll have Alice, since she was first, say hello to everybody. You can see the server received it, and then you can see the server does its job and relays the message back to everyone in the chat room. I'll go ahead and respond, hi Alice, and that works well. I'll go ahead and leave now to show you that that works. There's two ways to do it. One is by doing /quit, but I showed you that that already worked. So let's show you the way that's less clean and needs to be handled by just severing the connection and closing out of the application like this. Now you'll see that this actually works still. We've handled that error, and so that's good. And now let's add that last guy who wanted to join before but couldn't. We'll call him Edgar because that is the next letter in the alphabet, and then he can say hi to everybody as well. And that message is received by everyone who is still in the room. Alright, goodbye Edgar. And that's about it. Hopefully this was entertaining to some degree or informative. Thank you so much for watching.